Our next topic is sustained oscillation. Next we see the positive feedback op-amp as a oscillator. To see here what is the sustained oscillation, and this is also called a undamped oscillation. Observe this waveform. This amplitude is constant. Constant means this form is your constant. Means this is a time varying nature. This is a sine wave like sine wave means amplitude of both is constant, means positive and negative is constant. To observe this one, this amplitude is decreases, this is your decreases. Now this one called a sustained oscillation, also called a undamped oscillation. This is called damped oscillation. This is your undamped, this is your damped, this is your undamped. That is called also a not sustained oscillation. Overall means when the electrical oscillation in which amplitude does not change with time, this one represented here. This means maintain a periodic oscillations. This is maintain a periodic oscillation of a system with desired frequency, means this is a particular frequency which is produced by your oscillator. Means if the constant amplitude is come out, that is called as a sustained oscillation. This is your core, not a sustained oscillation, that is called damped oscillation. Also this is called undamped oscillation. These are the sustained oscillation property. Now to look the Barkhausen criteria is, there is two criteria. By this criteria, if any one oscillatory circuit follow, then output produced as a sustained oscillation. If this criteria is not follow, then you are not producing a sustained oscillation. Now what is the both criteria is, to see here. First one criteria is loop gain, means beta A is equal to unity. This is your first Barkhausen criteria. Next one, total phase shift suffered by a signal in traveling from input to output and back to input must be introduced a zero phase shift. Zero phase shift also called as a 360 phase shift, means you also call as this, because there is coordinate, you see here the zero phase shift is also 0 degree is also remained here, also there is a 360. Means overall conclusion of this one means total phase shift come zero phase shift, or other way also you say that the input to output back to input side, that is come in same phase of input. Means if these two criteria follow up, then your sustained oscillation produced by your oscillator. This second point is also here to see by this diagram. To observe this one, the second point means total phase suffered by the signal to traveling from input to output and back to input. This is how to represent here. This is your amplifier with feedback. This is your given a, this is a positive, this is a positive, both are the positive, means is this a positive feedback. This is represented here, means this is input. Now this is input is provided, this one. Now this is amplify, the output come here. Now again this feedback circuit to your input side move your signal. Now this complete path of signal follow, that is come zero phase shift. This is the represented here, means what is the input is also same phase in feedback your signal, then your proper sustained oscillation is producing by your oscillator. This is your second point, means overall conclusion, first and second point represented to oscillator circuit to produce a sustained oscillation. Next to move, your next topic is a positive feedback amplifier as a oscillator. To see here, we already seen the difference between positive feedback and negative feedback. The positive feedback, to see here, positive feedback, this is your positive symbol, means this is your summer, this is positive, this is also positive, means feedback is also added here, that is called as a positive feedback. Now this is positive feedback as a work as a oscillator. To see, observe here, this is your amplifier, this is your internal gain of amplifier is capital A, and this is a feedback network, is feedback factor is beta. Now the relation of your positive feedback, A of means feedback loop gain is equal to A 1 minus beta A. The oscillator, the ideal oscillator has the infinite closed loop gain or feedback gain. Now this infinite how come out, this infinite when this term value put a 0, means A upon 0, A upon 0 is divided, then come out your infinite. Then infinite is come, means this value is now put up a 0, this 1 minus beta is equal to 0. Now this arrange this one, this is come, this is your Barkhausen criteria. Now to observe this one, how we define a oscillator. We define a oscillator means when electronic circuit produces a sustained oscillation or desired frequency without given an external input, means this is producing a sustained oscillation, means the one of the term is defined here, means how oscillator is producing output signal without an external input. Now this is the explain here, the written some point here. To focus only here, the means what is the means by oscillator is producing the output signal without an external input. This is explained here. Suppose now this circuit is similar here, means this circuit now represented in this block. Now this circuit is now represented in this block. To observe this one, this is your amplifier block, and next one feedback network. This is a internal gain of A, and this is your feedback network of beta factor. Now we first consider a signal is applied, that is the represented here a small v to internal stage of your amplifier. Now this small v, whatever your input is apply signal, now this is amplified by your amplifier. Now this is outputs come in the output side. Now how the output is come, means this signal small v multiply by your gain, the output is come out, means we are represented here, means A multiply by small v, the product of this one is output is open here. Now again what happened, this is now feedback circuited to input of this one, this is your feedback input for this one, means whatever this signal is as an input for this feedback network. Now this is now output is come in this input side, means this is act as an input for this one A V is as an input of this network. Now this beta is now multiply output come here, means feedback output is come, what come, this is come, now we multiply by A V is your this amplified output is come here, this is your signal. Now this now multiply by beta A, means output here is come out of this product. Now this is now appear across this your input side, this one of the process. Now what we do the next step, now we connect Z and X terminal, Z and X terminal now connected, and remove this of small V voltage which is applied in a initial stage. Now we remove this one, now we remove this one, now this is connected. Now this equivalent circuit form, this form, means this is your equivalent circuit form. We remove a V signal which is applied in a first step and remove this one. Now this is formed as a closed path. Now what happened, this product means beta A V, which is appear across your amplifier, means this signal is now appear across this one. Now again this one amplified by your amplifier. Now if this gain, loop gain means beta A and small v is initial step we already applied. If this beta A is equal to 1, then beta A is equal to 1, then multiply by this is your product of VAV. This product are appearing in this input terminal. Now beta A we consider a 1. Now 1 we put here 1 multiply V. This equal to come to V. Means in the first step we apply a V. Now there is no need of your apply a as input. That's why we use here means no any external input apply. Means general external input as a no any apply, just as a input as a noise is present in a oscillator circuit, which is used for a oscillator circuit. To observe this one, this product means beta is equal to 1 using the Barkhausen criteria is beta is equal to 1, then 1 multiply V is equal to V, means again this is amplified, again this process is continuous, then is continuous, then your sustained oscillation is producing. Suppose there is a AC signal, means a sinusoidal signal is obtained by your this your oscillator circuit. This is constant amplitude, means only one initial stage we apply. After this we remove your whatever your signal is applied, and this is a now closed path is again amplified, and again to your feedback network again amplified. This is process continuous, and your oscillator is produced at a particular frequency of this signal. Now if beta A less than or greater than, what happened? Now to observe this diagram, the beta A is equal to 1, then your sustained oscillation come out. If beta A less than or greater than, what happen? If beta A less than 1, then your amplitude of your this sinusoidal is decreases. Means if beta is greater than 1, then your increases form. This happen. Means we generally we need a sustained oscillation. That's why to follow your Barkhausen criteria means beta is equal to 1. This is written whatever the explain here, means if beta is less than unity, what happen? Means less than the V, whatever you signal apply, then output is signal V will die out. This is represents here die out, means the decreases the amplitude come out to 0. Similar way, if beta is greater than unity, means this product is greater than V, then output signal will volt up, means growing oscillation. This is represents growing exponential. Similar way is written is beta is equal to unity, no change the occur in the input to output, and we get the output with constant magnitude, means undamped oscillation. This one is the undamped oscillation. This means to obtain a sustained oscillation, the loop gain of beta is positive feedback must be unity. These are the explanation of your when we apply no any external input. No any external input, this means for a small time duration, means initial stage we apply a signal. Also when we define again next step come to out, there is an input as a noise in a oscillator apply.